Hi friends! In this session, mainly aimed but not limited to intermediate level developers, I'll walk you through a demo implementation of how to use LangChain to connect to the Microsoft Learn Docs MCP server, discover available tools, and invoke a semantic documentation search. We'll do all of this using clean, modern async Python, making it practical and efficient for real-world use cases, even without an LLM. So let's begin by first defining MCP. MCP stands for Model Context Protocol, introduced by Anthropic in late 2024. It's an open specification that allows AI models to discover and invoke tools in a structured way using clearly defined schemas with input and output types, names, and intent. This lets agents reason about tool use without custom integrations or brittle assumptions. And here's the big picture. MCP is to AI agents what HTTP is to the web. Just like HTTP enabled any browser to talk to any website, MCP enables any model to talk to any tool, predictably, dynamically, and at scale. It's already supported across the ecosystem. LangChain, Semantic kernel, Claude, OpenAI agents, Microsoft, and others are using MCP to build interoperable, tool-aware AI systems. Now let's talk about LangChain. LangChain is an open-source framework designed to help developers build applications powered by large language models. It provides abstractions for common patterns, such as calling tools, maintaining memory across turns, chaining steps together, and implementing agents. LangChain is one of several frameworks in the ecosystem. Others include Microsoft's Semantic kernel, OpenAI's function calling, and Anthropic's Claude tool use system. What makes LangChain relevant here is that it supports MCP, allowing it to interoperate with external tools described using the Model Context Protocol. In this demo, we'll use that capability to connect to Microsoft Learn Docs MCP Server. LangChain is available in both Python and JavaScript and, among others, is widely used for experimentation and prototyping in the agent tooling space. In this example, we're not using a language model or agent. The goal here is to show how you can use LangChain's MCP client purely as a protocol adapter. We'll connect to an MCP compliant server, specifically Microsoft Learn Docs MCP Server implementation, discover the tools it exposes, and invoke one directly by passing structured input. This is a low-level, transparent example focused on how MCP works, not on model reasoning, tool selection, or planning. It's useful when you want to treat MCP tools as remote functions in a deterministic system, whether or not you are building an LLM-powered agent. Now let's walk through the high-level workflow of how this Python script interacts with the Microsoft Learn Docs MCP server. First, we initialize the MCP client by creating a multi-server MCP client instance. This sets up the connection to the MCP server endpoint hosted on Microsoft Learn. Next, we retrieve the available tools. We do this by asynchronously calling getTools, which returns a list of tool definitions registered on the server. Then we search through the list to locate a specific tool named Microsoft Docs Search. This tool enables us to programmatically query Microsoft documentation. Once the tool is found, we invoke it using an asynchronous call with a search query. For example, Azure SQL Database Backup Options. This triggers the backend to search the Microsoft Docs knowledge base. Finally, the results are returned as JSON. We parse this response and display relevant information such as the document title, URL, and an excerpt. In this slide, I illustrate the full life cycle of how the Python script interacts with the Microsoft Learn Docs MCP server using LangChain and MCP adapters. We begin at the top with the Python script, which is built using Async IO and LangChain. This script orchestrates the interaction and drives the logic. Next, the script initializes a multi-server MCP client, which comes from the LangChain MCP adapters package. This acts as the bridge between LangChain and the remote MCP server. The MCP client connects to the MCP server, which is hosted by Microsoft Learn. This server acts as a central point, exposing tool interfaces related to MS Learn Docs. The MCP server provides a tools registry listing all the available tools the client can use. The registry acts like a catalog. Among these tools, we specifically look for Microsoft Docs Search, which is responsible for handling doc-related queries. We invoke this tool with our query, and the tool responds with structured search results, typically a JSON payload containing document titles, URLs, and content snippets, and with that, the cycle completes. The script can then render or process these results as needed. This architecture allows us to build intelligent, asynchronous workflows over API-driven toolchains using LangChain. Before we see the code, let's quickly cover what you need to run this example. You'll need Python 3.9 or later, which comes with a built-in async I/O module and 3 packages: LangChain, LangChain MCP adapters, and AI OHTTP. These give us the necessary tooling to connect to an MCP server and interact with tools in a structured way. You don't need any access to a language model, API keys, or cloud accounts for this demo. We're working directly with the protocol and tools themselves, no reasoning loop, no agents. And while it's optional, even though I did not implement it in this example, I recommend using a virtual environment to keep things clean and isolated if you are testing in parallel with other projects. So let's begin examining the code. The first step is to install the necessary libraries and then import them in the code. We install the libraries contained in the requirements text file using the pip install command, and then we import them in our code. The next step is to initialize multi-server MCP client and point it to the Microsoft Learn Docs MCP server. This creates a gateway to the tool ecosystem. Using the getTools function, we fetch the list of tools available from the MCP server. This includes everything exposed for semantic search and more. Now we loop through the tools to find the one we're after, Microsoft Docs Search. This is what enables our doc querying capability. The final step is to call the MS Docs Search tool along with passing the payload, that is actually our question, and then parse the returned JSON string in order to present the results in a readable format. It's important to note that we need to call the tool asynchronously, hence the use of invoke, since the tool is asynchronous and we need to wait for the results. Also, note that even though in this example I'm not using an LLM, if I wanted to extend the example, I would use the LLM in order to pass the retrieved results and present them in an even more readable format and context. Now, let's run the program. As you can see in the output window, my program successfully connected to Microsoft Learn Docs MCP server and found the tool Microsoft Docs Search. The next step is to enter my question about the content I'm looking on Microsoft Docs, and the MCP server will reply back to me with a JSON payload that will be including 10 results, where every result will have a title, URL, and excerpt. As you can see in this screenshot, I passed to the MCP server's tool call as a parameter the question Azure SQL Database Backup options, as I wanted to search Microsoft documentation about this topic. We can see that the MCP server responded back to us with its findings. In this screenshot, we see the first result, and if we scroll down the output window, we'll see that it returns in total 10 results, where each result contains a title, URL, and excerpt of the relevant document found. Now let's recap. In this demo, we built an async LangChain integration with Microsoft Learn Docs MCP server, discovered tools, invoked a semantic doc search, and parsed the results, all modular and ready for scaling up. Future work may include incorporating the use of an LLM, enhancing the user interaction, and more. Thank you for watching this lecture. I hope you found the subject as exciting as I did. For more insights on AI, data, digital transformation, and other tech trends, subscribe to my channel on YouTube. Take care, and I'll see you next time.